Good evening, everybody. It's great to be here. My name is Kathryn Materna. I'm a second-year graduate student from UC Berkeley. And so the topic of tonight's session is a really big one, the future of geodesy. So I've decided to focus on a very small thing that I think we can do to make our lives a little bit easier in the next few years, namely how we compare and contrast different models, different individual results from different analyses for some of the biggest problems that we face. So first, I'll step back and say, what are the applications of geodesy? What are we looking at? In the specific case of the lithosphere, which many of us study, we're often looking at problems that have to do with coseismic slip, interseismic slip rates, plate coupling, a whole range of other applications, but I'll be focusing on the first two in this talk. In this room, we study basically all of these, and it's a vast field. But very often, we're doing our science in pretty much the same way. We have a common workflow that often starts with asking a question, which could be anything. But in the field of tectonics, it's often something like, what happened during a particular earthquake? Then we set about making a series of choices. What's the data we're going to use? What sort of processing scheme? How are we going to define our fault geometry, our rheology? We make a lot of decisions that eventually go into a model that helps us address the problem that we're asking. This common workflow that most of us use also involves, usually, individuals or small groups working on these questions that basically take a data set into a model, then we use that model to make an inference about the Earth, and eventually, maybe many months later, a paper comes out of this effort. I will note that this whole process speeds up dramatically after an earthquake. So this workflow that we all use results in us as a community generating a lot of coseismic slip models for the big events that we study. The Tohoku earthquake is probably the best example. I've heard that there are something like 200 coseismic slip distributions in existence that we have produced. And each of those slip distributions is the result of a series of modeling choices that somebody has made. Each of them are different, and we all set about doing it in different ways. Each model may not be a true representation of what actually happened in the Earth during this earthquake, but when we look at them all together in an ensemble, we get an interesting picture. Here's three more. We have areas in which these models agree, and those are areas where we can be quite certain that our science is telling us something akin to reality, and we have areas where these models disagree. And again, those tell us something really interesting too. They tell us what we can't see. Another problem, similarly big problem that people are working on and they approach in different ways is the interseismic slip rates, the creep rates on the Hayward fault, a fault in Northern California that is creeping in some places and locked in others. So here we have three distributions that come from different geodetic data sets for interseismic creep on the Hayward fault. And again, there are patches that agree. These are not identical, but there are patches that disagree as well. And the comparison of them tells us something closer, that we think, to what's actually happening. So when we think about models, or more specifically ensembles of models, I think it's really important that comparing the different models that we produce in the field, I think it's something that we should do more of. Basically, these comparisons show us the strengths of different data sets, potentially the blind spots of different data sets, and they're important for building consensus in the community for what we actually can understand. I think that building ensembles of models will become even more important in the future as new data sets start to come online. So when I think about the future of geodesy, I think, how can we make this easier for ourselves? One example is to create a common location, for example, a database where we can pool our modeling efforts. This will help us understand the uncertainties associated with what we do, help inform our decisions, and we can build this up as a community resource because in the case of the Tohoku earthquake, for example, 200 slip models are definitely better than one. I learned that in the seismological community, something like this does exist, and it's a database that is definitely worth checking out. Most of the models, there's something like 21 for the Tohoku earthquake and a number for other earthquakes, are based on seismic data sets rather than geodetic data sets. And I hope that in the future of geodesy, as we move forward, that the common workflow that many of us use can involve this one extra step where we make our models and it's in addition to just publishing them, we send them to a community resource that helps make it easier in the future to compare what we're all doing as the field. Thank you.